Assalamualaikum and a very good day to everyone. So today we're going to continue with our next topic, which is steels. By the end of this session, all students should be able to explain the basic science and engineering fundamentals pertaining to type of steel, property of steel, manufacturing process of steel, steel products, advantages and disadvantages of steel, and the protection of steel. Steel is used. So introduction, steel is used in a variety of types and forms in every building. It also the strongest, the most resistant to aging, and generally the most reliable in quality. So steel is completely industrialized material and subject to its tight control of its content and the details of its forming and fabrication. It has additional desirable quality of non-combustible, non-rotting, dimensionally stable with time and moisture change. What are the main properties of steel? Number 1, strong under compression and tension compared to concrete and timber. It can resist excessive load due to wind, earthquake, vibration and impact transfer load. What are the factors in selecting specific application of steel? Number 1, strength level required. What the level of strength? Mechanical properties required together with the strength. What are the mechanical properties of the steel? Steel making, heat treatment and other plant available, and arbitrary local conditions and code of practice. Structural steel can be divided into 3 main categories. Number 1, frame structures. So it consists of skeletal framework which carries all the load. The steel members are used to carry number 1, lateral loads when acting as beams and girders, axial loads when acting as struts and ties. So the steel frame are made of load-bearing elements, for example, tension members, columns, beams under combined bending, girder, trusses and axial load. For example, beam girder. Girder is a large support beam used in construction. Dome is a common structural element of architecture and resembles the hollow upper half of a sphere and trusses. So the first figure you can see is a girder, second one is a dome, and the third one is trusses. Number 2, shear type structure. It carries axial stress load. The shear can serve a use function in addition to participation in carrying loads. The main stress intention is the containment vessel. For example, containment vessel used to store liquid, water tank and storage bin. So we have example of water tank as shown in the figure in the slide. The third one, suspension type structure. Axial tension to support system. Major supporting element is tension cable. Since the tension element is the most efficient way of carrying load, structures utilization this concept are coming into increasing use. For example, cable, suspension cable. So as you can see in the figure below, there's a cable that hold the bridges from collapse, so it can sustain any load for cars moving across the bridge. Then we go to type of steel. So there is an almost infinite number of kinds of steel available, since it's possible to make steel to perform under most known conditions. What are the uses of the steel? Number 1, steel for strength, to resist impact, to resist corrosion, abrasion, steel to take and hold a sharp edge, steel to cut other steel. So basically steel is composed of about 98% of iron, with the main alloying elements of carbon, silicon and manganese. So the design of steel structure is based primarily on the yield stress or the proof stress of the steel, but ductility, toughness, and normal and weldability are often important properties. So the yield strength, or we call it yield point of a material, is defined in engineering and material science as the stress at which a material begins to physically deform, right? Means that from the elastic and then change to plasticity. So prior to the yield point, the material will deform elastically and will return to its original shape when the applied stress is removed, right? So weldability is important because welded structures give weight saving and ease of fabrication compared to bolting and riveting. Steel is derived from two raw materials, which is liquid pig iron and scrap. Pig iron is a raw iron, the immediate product of smelting iron ore with coke and limestone in the blast furnace. Pig iron has a very high carbon content, typically 3.5%, which makes it very brittle and not useful directly as a material except for limited application. So the iron making blast furnace produces liquid pig iron from the number one, iron, ore, limestone, coke, air. So the scrap used for new steel making arises in the steelwork itself, readily characterized and usually recycled completely. So we have example of the material of coke, and then we have limestone, we have iron ore. Two-way used in the creating and made of pig iron. Because of this, they are dubbed pig weights or simply pigs. Alright. Chinese iron workers smelting iron ore to make pig iron and wrought iron. This illustration is showing the puddling process on the left, while the right half displays men operating a blast furnace. This is an example of steel scrap, and then we have pig iron scrap. Steel for structure used in hot roll application may be classified into three main categories. Number one, carbon steel, high strength low alloy steel, and then we have alloy steel. Types of steel. So the first one, carbon steel. It contains iron, 1.7 carbon, 1.65 manganese, 0.5 silicon, 0.6 copper. C, manganese, carbon, increased strength, gain strength from finer microstructure during cooling process. And then we have low carbon, and then we have mild carbon, we have medium carbon, and then we have high carbon. And then under high strength low alloy steel, it is a carbon steel with addition of alloy element. Alloy improves some of the mechanical property and better resistant to atmosphere corrosion. And then we have alloy steel. Carbon steel undergone heat treatment. Consists of quenching, which is rapid cooling with water or oil from temperature 1650 Fahrenheit to 300 Fahrenheit, then reheating to 1150 Fahrenheit and allows cooling. Temporarily reduce strength and hardness but improve toughness and ductility. And then we go to manufacturing process. So primarily steel making. It refers to refining process used to produce steel, liquid steel. The aim is to produce a melt of the required composition. So typical range required for structural steels are carbon 0.15 to 0.25%, manganese 0.5 to 1.5%, sulfur and phosphorus less than 0.05%. And then types of refining process. The Bessemer or Thomas process, we call it. The open earth Siemens process. The basic oxygen process. Electric arc steel making. Okay, what are the secondary steel making? The liquid steel process is not finished when it is tapped from the furnace. It must undergo further treatment. For example, it is necessary to deoxidize the metal. This is done by adding the manganese and silicon, which react with dissolved oxygen to form insoluble particles of oxide. It may be necessary to adjust the carbon and manganese contents to give the grade of steel required, because with carbon it will improve strength and manganese give low temperature toughness. Mechanical forming process are used to convert ingot or continuously cast material into the shapes and size required. It can be done either by hot rolling or cold rolling. What is hot rolling? Hot rolling is air conditioner steel are hot roll. These steel are heated to temperature of 1200 to 1200 degrees Celsius to make them soft enough to deform and shape. And then cold rolling. Cold rolling cannot be used to the same degree as hot rolling for shaping purposes because of the increased strength of the cold workpiece. Modest reduction can be achieved by rolling to give better size tolerance and surface qualities, mainly for lightweight sections. Product of steel, we have hot roll product as mentioned previously, and then we have cool rolling product. So what is a hot roll product? Roll and form section, compound section, build up section, as shown in the figure and in the slide. Hot roll product. So we have roll and form section, compound section, build up section. So roll form section, the steel are heated to temperature 1200 to 1200 degrees Celsius to make them soft enough to deform shape. For example, universal beam, channel, hollow section, universal column, angle, and T. And then for compound section, combining separate roll section. For example, universal beam covered with cover plates, two angles welded together, two channels are welded together. And then we have build up section, welding plates together to form eye, hinge or box members, used to carry heavy loads and long span. And then reinforcement is concrete. Two types of bar. This is for reinforcement that have been integrated in concrete. So there are two types of bar used in reinforced concrete. We have hot roll mild steel, which is Fy equal to 250 Newton per mm square. And then we have hot roll high yield bar, which is Fy is equal to 460 Newton per mm square. So mild steel in the form of smooth round bars. High yield bar are produced in deformed bar. Other steel products include pre-stressing steel, stainless steel, and weathering steel. And then we have pre-stressing steel. Pre-stressing steel, or we call it tendons, are produced in the form of wire and strand. Steel for pre-stressing material may be made by any process except the air and mixed air oxygen bloom process. Pre-stressing are used in construction of bridges, buildings, steel, and other types of construction. There are three types of pre-stressing, which are wires, strand, or bars and bars. Weathering steel is a type of steel that develops a protective oxide coat on its surface upon exposure to the elements so that painting is not required for protection against most atmospheric corrosion. Suitable for use on bridges, buildings, and for decorative effect. Okay, this is for weathering steel. When it's exposed to environment, we use weathering steel. Stainless steel is defined as an iron carbon alloy with minimum of 10.5% chromium content. The name originates from the fact that stainless steel does not stain, corrode, or rust as easily as ordinary steel. This material is also called corrosion-resistant steel when it is not detailed exactly to its alloy type and grade, particularly in the aviation industry. As such, there are now different and easily accessible grades and surface finishes of stainless steel to suit the environment to which the material will be submitted in its lifetime. So these are a few examples of material that use stainless steel. For example, handrail, and then we have buildings of stainless steel. And then we use for connection. Three principal systems for connecting member: bolting, riveting, welding. Connections need to join members together in trusses. Connections need to join members together in trusses, plates together to form build-up members, beams to beams, trusses to column in structural frame, and column to foundations. As shown in the figure, we have bolt and base plate connected together to withstand the retaining wall. Bolting. Ordinary bolt in clearance hole consists of black hexagon head bolt, nut and washer. Force taken by share of bolt body. High strength friction grip bolt. It is made from high strength steel. Clamping force will transmit the force to the connected member by friction. Surface in contact must be free from mild scale rust, paint, grease, which would prevent solid contact between surface and lower the slip factors. This is an example of the bolting. And then we riveting. There are several common methods of technique for performing riveting operation. So there are standard hand riveting with a bucking bar or a blind rivet. Three basic alternative methods of riveting are cold riveting, automated riveting. So each method is used to achieve different characteristics. In the standard riveting process and in cold or hot riveting, a buckling bar is used at the bottom end of the rivet to cause it to form a head when the rivet is driven through the hole. Buckling bars are of different weight depending on the size of the rivet being used. So this you can see a few types of riveting as shown in the slide. Cold riveting process. Rivets are kept in a refrigerator until they are ready to be used. Rivet is driven until it is still cold. The rivet remains soft and more malleable. Rivet will cure at room temperature and become hardened, necessary for rivets produced from certain aluminum alloys. So this is how the rivet is being driven to steel material. And then hot riveting process. It is done for the same reason. Rivet will be at room temperature before it's used. When the rivet is needed, it will be heated and then driven while it is still hot. When it cools again, it will return to its hardened state, as shown in the figure on the slide. And then automated riveting process, which is quite cheaper, but due to lengthy setup time, they are usually limited to one rivet type. Automated riveting can include the hot and cold riveting method, as shown in the figure, which is rivet machine, right? Rivet machine. Welding. It is process of jointing metal parts by fusing them and filling with molten metal from electrodes extensively used to join parts and members, attach cleats, stiffeners and plates, and to fabricate complete elements such as plate girders. It produce neat strong and more efficient joints than are possible with bolting. We have two types of welding joint. The first one, butt welding, fillet welding. Size of the fillet specified by the leg length. Strength of weld calculated on throat thickness. So we have the first one, figure butt weld, and then we have fillet weld. This is few types of butt welds, okay, and then we have fillet welds shown in the figure. You can go through the types of butt welds and fillet welds, okay. Advantages of steel as structural material. The first one, high strength per unit weight. The load is small, so it is good for long span bridges, tall building, poor foundations. Number 2, uniformity. Property do not change with time. Third, elasticity. It is follow Hooke's law. Number 4, permanence. Maintained properly with large long. Number 5, ductility. Withstand extensive deformation without failure under high tensile stress. When a mild steel member is being tensioned, so considerable reduction in cross section and large amount of elongation will occur at the point of failure before actual fracture occur. It does not have this property, so hard brittle might break if subjected to sudden shock. So under normal loads, high stress concentrations develop at various points will yield locally at those points, and it also prevents premature failures. When overloaded, their large deflection give visible evidence of impending failure. Right? Number 6, addition of existing structure. New bays, wheels can be added to existing steel frame building. Steel bridges can be wide. Number 7, miscellaneous. Ability to be fastened together by several simple connection devices. For example, welds, bolts, rivets. Adaptation to fabrication. Speed of erection. Ability to be rolled into a wide variety of sizes, shapes, toughness, toughness and fatigue strength. Possible reuse after a structure is disassembled. We can disassemble for, let's say, all building of steel, and then we can use back the steel, and then we can use for another structure, or we can melt it again to produce another new steel material. And then in terms of economy, through mass production of standardized items. What are the advantages of steel as structural material? Number 1, firstly, maintenance costs. Quite costly, susceptible to corrosion when exposed to air and water, that need to be periodically painted, so increased cost. Fireproofing cost. Steel is an excellent heat conductor, may transmit heat to other sections, causing fire to start in the next building or room. So we need to add fireproofing layer, and then it will increase cost. Number 3, susceptibility to buckling. Danger to buckle and not economical since required to stiffen the column against buckling. And you have fatigue. When subjected to cyclic loading, steel strength will be reduced. Steel properties. Number 1, brittle fracture. Steel is ductile at above 10% degrees, but become brittle at temperature fall, and fracture can occur below 0 degrees Celsius. Stress reaction in structural steel. We have shown in the figure, we have low tensile steel, we have high tensile steel. For low tensile steels, so we have upper yield, and then it goes down to lower yield, and then we break at 250 Newton per mm square. For high tensile strength, it goes up at the beginning of the load, and then it breaks at 460 Newton per mm square, much higher than low tensile steel. So the figure is basically stress against strain for both low tensile steel and high tensile steel. Number 3, corrosion of steel. Exposed steelwork severely affected by corrosion in the atmosphere, particularly if pollutants are present, and this is need to surface protection. Water soluble, it can accelerate further corrosion. Atmosphere containing chloride or sulfur oxide, and then further accelerate the corrosion. Type of protective coating to protect the steel. Number 1, active coating. We call it cathodic protection or galvanized. Zinc coating on steel provide protection galvanically. The zinc is anodic to the steel, which is cathodically protected. The zinc may be sprayed on applied by heating the surface in contact with zinc powder. Alternative to zinc are aluminum, which act in the same way as the zinc. So the member is coated by dipping in a bath of molten zinc in the galvanizing process, spraying or electrolytic deposition process. Electrolytic process give thinner coatings. Type of protective coating, right? Number 2, barrier coating. We have inorganic. This include animals and cement. Although it is usually taken to maintain barriers produced either by surface modification or by painting. And then we have organic. Thick coating or substance such as pitch, tar, and bitumen are useful for steel structure to be buried in earth, usually in association with cathodic protection. In the cathodic protection, the cathodic partner is protected by the corrosion of an anode by imposing a current so that the area to be protected is made sufficiently cathodic. And the painting of various systems are used. One common system consists of using a primer of zinc chromate followed by finishing coats or micaceous iron oxide. The paint system normally consists of primer, undercoats, and finishing coats. Paint can give good long-term protection if applied by brushing and spraying. All paints are permeable to air and water vapor to some degree, and the protection afforded is directly proportional to the thickness of the paint. And then we have plastic coatings. Steel, especially in sheet form, can be coated with protective and decorative plastics. The coatings are adherent and can withstand mechanical shaping methods such as folding and even deep drawing. They are widely used for cladding and roofing. Universal beam, very efficient for resisting bending moment about major axis. So this type of universal beam, this is for I-beam, for example. This is universal column to resist axial in load with high radius of gyration about the minor axis to prevent buckling the plane. Universal column, as shown in the figure. We have channels used for beams, bracing members, truss members, and in compound members. Right, this is shown in the figure is a C section because it's quite similar with C section, C. Hollow section produced from flat plate. Circular section is made first, then this is converted to the square or rectangular shape as shown in the slide. Angle and T, produced by cutting universal beam or column into two parts, used for truss, members, ties, and light beams shown in the figure. Alright, angle and T. Compound section. Okay, universal beam covered with cover plates on top of the plate as shown in the first figure. And then number 2, angle welded together. So we welded together the angle. And then we have 2 channels are welded together. Okay, and then we have our box section. Build up sections shown in the figure below, shown in the figure on the slide. This is build-up section. And then we have wires, strands, and bars. So wires made to BF 5896 1980 is made of cold drawn with high carbon content steel wrought through a series of reducing dies, may be crimped mechanically or have surface indented and improved bond when used in short units. And the strand, 7 wire strand made to BS 5896 1980 is made by spinning 6 cold drawn wires in helical form around a slightly larger straight central wire. Then it is stress relief or hot stretch. Bars, pre-stressing bars to BS 8886 1988 are made by hot rolling microalloy steel under controlled conditions and then stretching them in controlled manner. May be plain or deformed with a maximum length of 18 meter. The prepared ends are threaded by cold rolling, can be joined end to end by couple. So we have a figure of steel wires, steel strands, steel bars, right? Okay, and then buckling and blind rivet. So this example buckling rivet, blind rivet, right? And shown in the figure.